Swayam Prabha. Digital India. Educated India.
Dear students, I welcome you back to the lectures in the course series of Transportation Engineering 2. In this course series, we have already covered a lot many aspects on railway track. In the previous some 3 or 4 lectures, we have been discussing about the geometrics of railway tracks, where we have discussed about the horizontal profile and the vertical profile of railway track. In today's lecture and the 2 or 3 lectures more to come, we will be discussing about another specific aspect of railway tracks, that is turnouts. The turnouts are divided in 3 forms, that is, we will be looking at the components, we will be looking at the different type of crossings, and we will also look at the various types of designs which needs to be done related to the turnouts and the crossings. In today's lecture, it has been outlined with the following. We will be discussing about turnout. We will discuss about the different types of the turnouts, that is the left hand turnout and the right hand turnout, and we will be discussing about the various components of a turnout. Another thing is that we will be discussing about the points and switches related to turnouts. Starting with turnouts, the turnouts can be defined as the simple arrangement of points and crossings which enable the movement of train from one route to another. This is a condition where we are interested in changing the direction of a track. In the previous design features which we have discussed in the geometrics, what we discussed is there is a single track which is moving in a horizontal or the vertical profile, and therefore, we have tried to design that. Now, in today's lecture, what we are discussing is that there are 2 tracks which are either merging or diverging from each other, or there may be some tracks which are moving parallel to each other and still they are being connected with each other. This connection between the 2 tracks, or the merging or the diverging of the 2 tracks from each other, helps in changing the direction of a train, and this is done, or this is achieved by using the 2 type of systems. One is the points, another one is the crossings, and when you use these points and crossings together, then what we get is nothing but turnout. The combination of lead rails with curved rails and fastenings helps in diverting the rolling stock from one track to another track. This is another part of the definition which tries to define that what type of main components will be there when you lay out any turnout. Now, in this case, what we are discussing, what we are trying to develop is that there are different type of rails depending on their straightness or their curvature. If the rails are straight, then they are termed as lead rails, whereas if they are having a curvature, then they are termed as curved rails. And obviously, whatever rails are provided, and they are provided over the sleepers, so fastenings have to be there. And this combination of the lead rail, which are the straight rails, when they are jointed with the curved rails, they help in diverting the rolling stock from one track to the another track. And these are also provided in yards, sidings, etc. That is an obvious reason, because in the case of yards and sidings, the main function is that we have to take the trains away as soon as they are they have completed their operation, that is their journey is over and they have reached the terminal points. So, they are taken to the yards where they are just kept as a storage, or they are also formed into the new train using the different cabins or the compartments which are available in the sidings or the yards, and then that new train is brought to the platform for further operation. So, in that sense there are different operations which are going on, and due to which the directions have to be changed, and this is why the turnouts are also required in yards, sidings or the similar sort of conditions. Now, we look at this diagram. This is a diagram which is having different tracks, like we can see there are some tracks which are coming from this side, then there are two tracks which are coming from this side, and these tracks are going further here, and again there are some divergence or the straight movement, and there is again this is a merging of the two tracks, that this track is coming from this side and this track is going from this side, and the two are merging here, and then they are again diverging and going in this direction. Similarly, there is a diversion at this point and the track is going this way, and we found there are some cabins which are standing at this location. So, this is maybe a side of a sidings or the yards on any station. Now, in this case, if a train is coming from this direction, then this is a one condition which is being provided here, which is known as crossing, helps it so as to take a turn and go or use this particular track instead of this track, depending on the requirements. So, this is a combination, this type of a combination along with another combination which is provided on other side, like here also we can see that this is a straight line and then there is a curved line being provided on this direction. So, using this straight line and curved line, here we are trying to divert a train so as to which can go from to this direction, or otherwise which can also go in the straight direction like this. So, we are interested in designing this part of the track, and this is what we will be looking in this lecture as well as in the coming lectures. So, but when you are talking about these turnouts, obviously there remains some of the problems. So, we look at those problems right now. These are the weakest points on the track due to joints and movable fastenings. We have already discussed about the joints, we have also discussed about the fastenings. Wherever there is a connectivity, that connectivity point becomes the weakest point, because there is no support being available at that location other than the fastenings being provided so as to connect the two components of the track. So, it means wherever the turnout has been provided, that turnout point location becomes the weakest point on the track, and in such condition the safety becomes the main consideration of the design. So, we have to look at that while making a turn from one track to the other track, there should not be any derailment or there should not be any over riding of the rails at that particular location. So, this is one of the aspects which needs to be taken care of. Then they also retard the movement of the train. This is another aspect, because at this point the train has to reduce its speed. So, when the speed is being reduced, therefore, the overall movement of the train has reduced and it takes a little longer time depending on the number of locations where the turnouts or the crossings have been provided. Now, we come to the various types of the turnouts. As we have just seen in the case of the layout, there are two types of turnouts which we will be looking at, the left hand turnout and the right hand turnout. But how they are going to define whether it is a left hand turnout or it is a right hand turnout? These are defined based on the direction of movement from the main track, and on the basis of that movement it can be a left hand turnout or it can be a right hand turnout. So, we will be looking at that how on the basis of this directional movement from the main track we can find out whether it is a left hand or a right hand turnout. Now, this is one diagram which is trying to show the overall composition of the points and the crossings which constitute any turnout. Now, in this case all the components can be seen very clearly. What we see is that this is the one rail which is provided. So, what we are happening is that there is one track which is being laid like this. These are the two rails of the track which are being laid like this, and then there is a requirement of changing the direction from this track in this direction. So, there is another track which is being laid, and here in this portion there is an overlapping of the two tracks. So, we are trying to facilitate the change in the direction by using certain features which have been provided along this one. So, what we can see is that it is a combination, as we have discussed in the definition itself, it is a combination of the lead rails and the curved rails. So, because this is a straight portion, so there is a lead rail on this side. Similarly, this is also a straight portion, so there is another lead rail on this side. At the same time, there is a curved section here and the curved section here. So, these are the curved lead rails, these are the straight lead rails, and these are the curved lead rails. Now, if we are coming from this side, then this becomes the outer side of the turnout. So, therefore, this is known as outer straight lead rail, and this is known as inner straight lead rail. Whereas, if again looking from the same direction, if we look at this one, this is termed as the outer curved lead rail, whereas this one is termed as the inner curved lead rail. So, this is how we are distinguishing between the straight and the curved lead rails, as well as within the straight and the curved lead rails respectively. Now, this portion is termed as points. These are the points and the switches being located here, whereas this portion is known as crossing, because the two tracks are crossing each other at this location. So, if we look at this crossing, first of all, what we found is that there are two rails which are coming like this, and they have been jointed together in this form. This is what is being done here, and then this curved rail which is coming from this direction is made parallel to this straight lead rail. So, this is being made parallel like this, and then it is flared towards the outer side like this. Similarly, on the other side also it is coming this way, and then it is made parallel to this one, and then again it is being flared like this. So, this is what is written is that this is a flare and this is also a flare on this side, and these two rails which have been made first of all parallel and then being flared, they are known as wing rails. So, these are wing rails, on one on this side, one on this side. So, there is one pair of wing rail provided on the crossing. Just opposite to this wing rail, there is another type of a rail being provided on the other side of the rail section, and the inside of that rail section which is parallel to that one and is flared on the two ends. So, this is another type of rail, this is one and this is one being provided on this side, and this is known as jack rail. So, this is another component, the wing rails and the jack rails being provided on the crossing of the turnout. Then this is an angle alpha which is defined here in terms of the angle which is being made by this one straight inner straight lead rail and the another inner straight lead rail of the curved section here. So, this is the angle alpha being defined here. This is also known as angle of crossing. We will be looking at that what is angle of crossing, how it is defined. And the two rails which are being jointed here, again they are of a specific nature, and at this location where they are being connected with each other, what we found is there are two types of noses. One is the theoretical nose of crossing, and the one is the actual nose of crossing. So, we will look at that what is this theoretical nose and what is this actual nose, we will discuss further. But just for a moment, what we are interested in to look that what are the different terminologies which are associated with any of the turnout. Now, similarly, when you come towards the points or the cross on this side, what we are looking is that there is one rail section like this, where there is some band in the rail section. Similarly, there is one rail section which is provided on this side like this, a straight portion, and this is known as the stock rail. So, we have the stock rail here, we have the other stock rail here. Then there is a rail section up to this portion it is curved, and then after it becomes straight. So, there is one rail section which is being formed straight like this, and this is another rail section which we can see is a straight rail section, and this is having a thickness equals to the same rail section as being shown here. The thickness here means this is the thickness of the rail head. So, it is having the same thickness at this point, but as we go further it becomes tapered and has a very small lesser thickness at the end point. So, this is this pair of rails, this is known as tongue rail. So, in this direct side what we are having a combination of a pair of stalk rails and a pair of tongue rails, and these two tongue rails which are being provided on the either side of the rail sections like this one, they are connected with each other. So, these are the bars by which they have been connected with each other, and these bars are known as stretcher bars. Okay. So, this is what is being shown this way, and then there is some distance at which this tongue rail will remain. So, this is a distance at which the tongue rail is, and this is known as throw off switch, okay, because this is what is the switch location. So, this is we are operating this switch so as to move these tongue rails to this direction or to this direction, depending in which direction the trains have to be moved. So, this is the distance by which it is moving, and this distance by which it is moving is known as throw off switch. Similarly, when we come back to this crossing side, what we found is that there is some distance which is being left here, and this distance which is being left here in this location between the two rail sections, and because of the bluntness of the connectivity of these two rail sections, what we found is that some gap is being maintained, and this gap is known as the throat of crossing. So, this is another terminology which we are using, the throat of crossing. And another thing is that these two rails which have been joined here, they are the point rail and the splice rail, and how we differentiate between a point rail and a splice rail we will be looking further when we take up another definition of those one. And here this is the facing direction. Facing direction is being taken with respect to this track where we are standing on the points and we are looking towards the crossing. On the basis of this one, then the facing direction is defined, whereas if we are standing on the crossing and we are looking towards the points, so these are the points and this is the crossing. So, if we are standing here and looking towards this one, then it is known as trailing direction. So, this is facing direction, and this way it will be trailing direction. Then further, starting from this point, this is the heel of our crossing, to this point, that is the last point of the points, that is the end of the stalk rail where we are having. So, this is the overall length of the turnout. So, this is what is to be designed. When we take the design, we have to design the curved rails, we have to design the straight rails, we have to design the overall length of this section, we have to design for how much distance these needs to be curved, and then for how much distance these have to be provided, what is angle alpha, and there is also one angle at this side, that is beta. So, what is that angle beta? So, likewise the design has to be done for this. This is another diagram, another picture basically of a track which is taken, and here we are again trying to show you that there is a one straight track, and from this straight track we are providing a flexibility so as to take a turn like this. Okay. So, it means we are providing a crossing at this location. So, this is what we can see, there is a crossing, we have a point and a splice rail provided here, this is the wing rail being provided on this side, this is a wing rail provided on this side, this is the curved section, this is the straight section, this is another curved section here. So, we have the inner or outer curved section, we have the inner or outer straight lead rails, and then on this side we are providing the extra safety features here in the form of maybe the check rails. So, if you are standing at the location of the points will be provided on this location, and if you are looking towards the crossing, then this is the facing direction here. And on the basis of that facing direction, we can define whether this is a left hand turnout or a right hand turnout. In this case, when we are standing here and looking in this direction, then this track is turning in the right hand direction. So, if it is turning in the right hand direction, when you are looking in the facing direction, it is termed as right hand turnout, whereas if it has taking a turn like this, then this will be a left hand turnout. In the similar form, this diagram also is trying to show you that what are the things which needs to be discussed or designed when a turnout is planned or designed. Here this is one track and this is another track, and we are providing a flexibility so as to take a turn from this track and come to this track, or if we are coming from this side, we can come this way and go to the another track like this. In this sequence, we will be designing the tongue rails and the turnout devices or the points or the switches at this location. Then we will be designing this crossing area, which is also known as frog area, that is based on the type of the designing we are having. Frog is a distance or a gap which is being provided. Similarly, if you are coming from this side, then we have these points or switches or in the form of tongue rails or the stalk rails, and then here also again we have the frog area. So, this is how the things needs to be designed. So, now we come to the various important terms which needs to be discussed, which we should know before designing any turnout. The very first thing is that what type of turnout we are designing, whether we are designing a right hand turnout or a left hand turnout. Now, I have already defined that how we can try and we can find out what is the right hand turnout or a left hand turnout. The same is being defined here, that while crossing in the facing direction, if the train diverts to the right or to the left of the main track, then the turnout is known as right hand or left hand turnout respectively. That is, if you are standing in the facing direction and crossing in the facing direction, that is what we have seen, that we are standing on the points and looking towards the crossing. Then if the train diverts to the right, then it is termed as right hand turnout, and if it diverts to the left of the main track, then it is termed as left hand turnout. Now, what is facing direction? The facing direction is the standing and switch and looking towards the crossing. So, this direction is known as facing direction. So, just stand on the points or the switches, look towards the crossing. Similarly, in opposite form, we can define the trailing direction. The trailing direction is standing at crossing and looking towards the switches. So, means now you just stand where the two tracks are crossing each other and look towards that direction from where the change of direction is provided, then that will become the trailing direction. Then points. Points is the pair of tongue rails with the stalk rails. The trains diverting from the main track will negotiate the points first. So, this is what we have seen also. If a train is coming from a main track from the facing direction, then it will be first of all crossing the points and then only it will be coming to the crossing. So, that is why this is the first device or assembly of